Cool. So yeah, Dinesh, if you wouldn't mind doing it today. And
Yeah.
I'm just going to leave now. So I'll catch up with you guys in about 40 minutes.
Okay.
Thanks. Bye.
All right. But okay. So we have, okay, 4 of us. So let's, today's new lesson, that's chapter 13. Yeah. So I looked at it. There are 4 different sections in this. So let's do, because there are 4 different days we're going to do this. So what I was thinking is, I'm just opening. Yeah. So let's do the data API today. So hold of the data API all the way when it starts just before the TF record format.
Just before it?
Yeah, so finish the data API, yeah.
Oh, okay, right, I see it, yeah. Okay.
All the way, yeah.
Okay.
Yep. Any question? All good?
When are we meeting back?
So we are 7 past. So let's meet at 10 to.
Yeah, sounds good.
Yeah, 10 to 7. Yeah.
Okay, cool.
Okay. Talk to you then.
Okay. All right. Bye.
Bye. Let's wait Maria to join in, and then we'll get it starting.
Okay.
Did you guys manage to read all of it?
Yeah.
All the way?
Yeah, just finished.
Good, 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 good. It's quite interesting, the practical bit as well.
Oh, I didn't even look at the notebook.
Yeah, I mean, like, it's good though. You have to go through a couple of times because it's the text is loaded,
Mhm.
so I get lost loads of times. So you have to go back and then see what exactly he's doing.
Yeah, there's a lot of detail.
Yeah, and that's what the complaint was on Sunday as well. That now the chapters, like a last chapter, chapter 12, was quite a packed information. However, the problem was it wasn't enough.
Mm.
So there was that there was a reference given, I think, a couple of times, couple of guys, the TensorFlow library itself, go there and have a look. I didn't manage to go there, but yeah, it's a good information over there.
Yeah. Yeah, the documentation is very good normally.
Yeah, yeah.
I'll just check if she's coming. Hey, there she is.
Yeah, there you go. Yeah, and I guess Arshad will join whenever he joins. Okay, let's get cracking on it. So loading data and pre-processing data with the TensorFlow. So basically, what he's talking about here in this chapter is that so far we have a small CSV. We have been loading into a memory with the read CSV and processing it. However, there will be a times where we'll have a data which will not fit in a RAM. So we do need some sort of a mechanism where we continuously read from the disk or a medium or a cloud storage or whatever, and then keep processing it. So for that reason, we have something called a data API. And the beauty of this data API is that once we start using it, it does all things like multi-threading, queuing, batching, and prefetching for you. So we will be going through all these concepts later on. So that's the first thing, data API. Once we done the data API, obviously we're going to go to TF record, which probably next Sunday. So what is a data API? Data API is nothing but just there is a concept of something called a data set, and data set is nothing but an object in the memory, and it interacts with the physical file or a database or anywhere where that data is sitting. So our model will take the data set, and data set is sort of like an interface. It's the framework which goes behind the scene, create all the transformation for us, all the parallelism for us, provide the data for us, and then it's talking to the disk. So that's what he's talking about here. So example he created, let's create the example of like 1, 2, 3, 4, and then let's play with it here. So I'm gonna switch to, I'll be switching between the two just for the sake of. So first cell is more or less just the setup. And interestingly, if you run the notebook in Collab, for some reason you get this error. So I'm not sure on the Collab, probably you need to upgrade these libraries before you run it. However, this is on my PC and it's working fine. So data set. data set is, let's say we fetch 10 numbers in an X, and then what we have done is we created tf.data.dataset, and we fetched, we slice the X, which is 10 numbers, and push it into a data set. And then we iterate over the data set and then print out the item. So, and if I print it here, did I print? Okay, so data set, actually this, I was running the files. So I'm gonna run this back again, and this again. So this, all it has done is nothing but just 10 numbers put into 10 different tensors. So now we have this data set which we can play around. We can do directly as well. So instead of like from tensor slice, we could do just take a range of a 10 number, push it to a data set, and then that value comes in here, and then we'll get the same result in here. That's what he's saying here. So that's how he has created the concept of a data set. So let's go forward. Chaining the transformation. So you can do lots of operations on this data set. So once that's built for you, you can do the operations like he has done. Is a repeat. The next one is a batch. So he's saying here, he's showing it here. Let me run this guy here. So what all he's doing is we build the data set before, which is 10 numbers here, 0 to 9. And now what we want to do is we want to repeat these 10 numbers 3 times. So that's the one transformation we have done. And then we have 3 times the data set. And then we want to get the batch of 7 instead of 10 together. On the right hand side, if you see it here, we had an X, and then X was sliced into 0 to 9. That was the first operation. And now we have done the second operation where we have just repeated 0 to 9 3 times. And once we have repeated it, we are batching the numbers out of these the three columns which you see. We're batching them together as a 7 numbers and printing them in here. And if you see in here, that's exactly what we're doing. First stage is create a data set, or rather make a transformation on the data set which you have created. The transformation is repeated 3 times and then batch it 7 times. And then once that's done, we are just iterate over the data set and print those over. So, oops, cannot batch it. Okay. So let me cannot batch tensor with a different shape in component 0. Having 4 had a shape 2. Okay, so there is, you see, we can ignore, say, drop remainder. True. No.
You'll run the line above, maybe
Yeah.
so you've applied the data set somewhere. So it's not what you printed.
Okay, let me, I'm going to start again. So I'm going to start. This is from very beginning. And that's printing fine. So these are the range of 10 numbers. And I am printing 10 numbers. Oh, I know what is it. And then I think, yeah, so this is the extra bit which I printed. Once this error you get usually when you try to iterate over twice. So I think that probably is the issue. Let me see this again. Yeah, so it's the, yeah, so now it printed here. So what happens is sometime when you try to print twice, you iterate over once and then you try to iterate over again, it gives you error. that was the issue. Am I on the right? Yeah, I am. Oh, I'm on the right place. Yeah. So what we were saying here is that's your batch of 7 now. Batch of 7. And if I just take it away, it might error because I have already iterated over, but let's try again. Yeah. What did it do? It did print the numbers, 7 by 7, but it's a different shape now. 1, 2, 3, 4, 5, 5 by 7 and 7 by 7.
So now you repeated like 3 times that data set of 4 rows, and now you have 12 rows in total.
Okay.
Yeah, it's still going.
Yeah.
Mhm.
Yeah. If I go this and do only this, then I should be fine. Yeah. And then 2 numbers came back here. Yeah. Thanks, Arto, for that. Yeah, absolutely. So yes, it's the same data set we are using. So the name is same. So we keep on storing. Yeah, one of the point he was saying was it always, when you make an operation, it actually not doing operation in place. However, you have to, like, it creates a new data set. So you need to store into a new data set, which is same. And that's why operation keep on repeating. Okay, so that's that. And then drop remainder true. If I mentioned in here, if you mention this true will be ignored. Otherwise, they got printed in here. And this is just, I was looking, once the data set get created, you can look at the directory dir of this. These are the different methods, inner methods, as well as I think these are available. Let me ask one question, if somebody can explain to me. We have a dunder 2 underscore, this is dunder letter or dunder class, and we have a single underscore. Anybody know what's the difference between the two? Double underscore and single underscore?
I thought the singles were internal, just internal, methods. I mean, the dunder is like, it's like inherited, but this is if you want to create your own internal stuff. But I'm not 100% sure about that. I just assume that's what they use it for.
So internals are which the library, they are the private functions within that class. It will be used by internally. And then you're saying these are the one which we can overwrite?
Oh, those are the ones that you inherit. So you get them from, is it object or something like that?
Okay.
Yeah. Whereas, I think, I need to look that up actually, but
okay.
I think that's
you can re-implement those if you want to define a class logic by yourself, like this. What happens if we create a new instance, and then you need to write new dunder new method, or what happens if you compare two objects, and there are a bunch of methods which are by default internally called when you use comparison operators, like that.
Okay, so I mean, like, these are the private one, and then last one is without. So they are just the methods available with this object, which we can use it.
I don't think Python, well, yeah, I don't know much about Python. I don't know if it actually has private public, like you get another, like you get like in Java.
It's just a convention in Python.
It's just a convention.
You can mess with those private methods, but because they are not actually private, but you're not supposed to, so they are marked with this underscore.
Okay, cool.
Okay. Right. Okay. So, and then I was just looking what type of object it is. It is like best data set as such. Okay. So moving to the right hand side, then you can you can also transform the item by calling the map method. So what he's doing is like on the data set, we can apply our own function. So here he has applied a function where it's just going to multiply everything by 2. So that's the number here. And so everything got multiplied by 2, if you see here. And then the next method on the data set is, I think there is, this function didn't work, unbatch, but this unbatch is in an experimental stage. Let me try one more time. Oh, this time it worked. I think last time is the same thing. I may have run twice, or I may be somewhere else. And actually, he had this guy in here. So, okay, got the same method again. So I think it's because I have run it once, and on a second time when I run it, I'll get the error because it's unbatched already. However, the point is, he says, while the map function applies a transformation to each item, the apply method applies a transformation to the data set as a whole. So in here, he's doing, he applied the function to the whole batch, and up above it, this function map was applied individually to each item. Makes sense, or anybody wants to add anything?
No, that's cool.
Okay. Then in here, he's just saying you can also apply a filter so that you just want the data, like let's say in here we have this data, you're looking for a data only which is less than 10. You can apply a filter, simple filter in here, and then data get filtered out for you automatically. So another operation we are making in here. And the next one is yeah, okay, so the next part is a buffer. So buffer is just the concept where he says it's the out of a 7, how many numbers, like let's say if you have a RAM, you give a buffer size, and buffer size is basically a set of a memory allocated for you where the data will reside for you. That's the buffer size. So every time, let's say if you say buffer size is 3, so that's the number. 3 numbers are going to store at a time in a memory for you, and then once you have fetched them, like fetch and printed them here, it goes, those buffer will repopulated with the next 3 values, and so on and so forth. So you can't make much out here in the form of output. It's the concept which he is saying is how much you, if you have a bigger data set, how much buffer you're going to create in a memory so that your data can continuously stream into and available for you to process it. So that's actually what I gather from the whole point in here. Anybody wants to add anything in here? Okay, so let's move on to the next important part, which he mentioned in here, and that's all about the next concept, where, as I mentioned here, how the data is picked up from the files, how it's shuffled, and then how it's supplied. So one of the point is, why do we need it? I think one of the point he's trying to make here is, let me see, he mentioned gradient descent. Yeah, so in a gradient descent works best when the instances in the training sets are independent and identically distributed. So what he's trying to say is, let's say if we load this guy in here, we would have a data which is, let's say, data for a region or particular blocks they are sitting together. That creates a bias in a model. So for a gradient descent, for a gradients descent, he mentioned that the better it is if the data is shuffled, if the data is random. However, what the point he is trying to make here is that that shuffling of a data, your data set API is going to do. However, it's better if you do that on the operating system level as well. So in this exercise, whole exercise, all he is doing is taking a data fetch from California housing data set and creating the smaller files, which is going to store into a disk, and then start reading those files randomly in a batch. And within those files again, you may have a data which is sitting, one data point is sitting next to another one, not shuffled. And what he's trying to do there is, he said, you should be shuffling that data as well. So the whole exercise is shuffling of data in this paragraph. Am I making sense, or it's overboard?
No, makes sense.
Okay, so in this whole paragraph, that's what he has done. Let me see if okay. So I'm going to walk through this function. First of all, obviously, fetch the California housing data set, training, test, split, and a scalar. We fetch the data. We got the data for a training and test set. And again, the training set is split further into training and validation set. And we scaled all three of them. Training, test. Oh, so he had just trained. He scaled only train at the moment, not the test and validation. And he calculated mean and mean in here and standard deviation. That looks to me a mistake. Standard deviation, he should have done the scalar.std rather than a scale. Yeah, that seems to be a mistake. Okay, so next thing what we are doing is, this is save to multiple CSV files. So all he is doing is, I'll show you now, he picks up the training test and validation data set and spit into a CSV files. So if I ran this before, so if I show you in here, what he does is he whatever your directory is, he create a dataset directory. Within it create a housing folder. And if you look at the housing folder, he has created these my test files, my training files, and my validation files. So going back in here, he took the data from the internet and spit out into this file. And this is whole he's doing here. Now, let me walk you code quickly. So housing directory dataset under housing, and then he makes the directory here. The file name is going to be my underscore whatever we pass. We pass train, test, and validation, and then he gives a number 01, 02, 03, so on and so forth. Quickly here, he just take the length in a M and enumerate on it. So if file index, row index, and enumerate on the number which we got from the length of a data, and data is going to get passed into a function. And then part CSV, just formatting it into a CSV, adding the data into a CSV, open that file in the disk, and then wrote the header. If it's not none, then write the header. If it's none, if it's not none, then write it in here, and then wrote the rest of the rows. So that's the function he has created in here. And the whole idea, the reason why he is doing all this is, what he wants to do further on the training files, he will pick 5 files at the time, and from those 5 files, he is going to create the data set. And within those 5 files, he's going to pick one row from each file at a time. And now you have the full randomness. You have a randomness of a data going into these files, and then you have a randomness when each individual row is coming from each file. And then now you have established the randomness within on the operating system level, plus you'll use a function further on in the dataset API to shuffle the data, so on and so forth. And this is whole exercise is for that. Okay, so as I was saying, one question I have, I didn't get it. So he's creating train, validation, and test data from the X-train, Y-train, which we created above. Anybody know what is this? C underscore.
I thought it was some sort of concatenate function. I've seen it before, but I can't. Yeah, I think it is some sort of concatenation.
Concatenation.
Yeah, it is. Yeah.
Okay, just give me 1 second. I'm going to note down and then maybe.
I didn't really remember that. Okay.
C underscore. Okay. And then you have header columns. All the columns are going through separated by the comma. And save to multiple files, as I showed you, like train, valid, and test files are going to be saved. So this has been saved. And let's go and then check out file, any file you can pick up. File, let's say 0, he had it 0 before. So that's data coming in. These are the files. This is the raw file. Again, this text is nothing but picking up the raw file and showing you the raw file. This is like where are the files are sitting in. So it's setting in a data set, housing, and train 00 CSV. So that's that. I'm like on the operating system level, the data has been scattered. So to remove any bias. So we're going to use this in here. So okay, so this is exactly the same where they are sitting, the files are sitting. Now, in this mode, I'll go here and then interleaving lines from the multiple files. So this method, interleave method, that's what he's explaining. Again, we are going to pick up a files. So that's the method he has. We are going to pick up file 5 at a time. And when he says interleave, so interleave will going to pick up one line from each file, and then create a batch and pass it on. And that's what he's saying here. So we created the data set from the files which we were here, and then he mixed them up, and then that's what he's printing. So oops.
Is the dot skip, is that to do with the row names? Yeah, the column names from there.
Sorry?
At the end of the Lambda function, it says a dot skip bracket.
Yeah, so that's the header.
Okay, yeah.
So that's to, because all the files have, let's open one file. And if I just, yeah, so it has a header here. So it's gonna pick. So that's the raw data from line 2 onwards it's going to pick.
Yeah, cool, thanks.
Okay. Going in here. Okay, so these 5 lines, he said take 5 from a data set. And now these 5 lines are coming from 5 files, 5 different files, rather than from one file. And that creates the randomness of a data in here. And that's what he's trying to explain in here. That's what the interleaving lines from multiple files meaning. Yeah, so that's that. Okay. Okay, so the next thing is pre-processing the data. So pre-processing is basically what he's trying to do now is take that data and sort of create a default value from them, do the this bit, what do you call it, normalization. Is this a normalization process where you subtract by mean and divide by standard deviation? So that's the process he's doing in here. But now here he's again explaining something, is like creating the default values for, we have 8 fields. So we have 8 different fields in a California housing, 8 features rather. So we have 8 features and 1 target. And what he's doing here is he has just defined defaults. So first column will have a 0 default, second column will have a nan, third column will have a float, fourth column will have the string, and fifth column will have a constant default. So he's just demonstrating here, if you have, let's say, value 1, 2, 3, 4, 5, and if you say record defaults are the defaults, which we defined here, you're going to get these values in here. So he's just demonstrating, because he's going to use these default in a function later on. And that's all he's doing. So let's say we run these values on the and see what default they get. So I'm gonna run this. So if you see, we have default 0 for this. We had nothing here, so we got none. This got float value but non-value here, and we have hello, that's hello default value, and a constant TF constant value 5. Oh, because we have a 5 in here. And another thing which he was saying is, next one is, if you don't specify the constant value like he did here, you'll get the exception. So field 4 is required. So last field you have to have it. So if we get, let's say, any value, we won't get the exception, but if we have 0 value, we get the exception. So just demonstration here about the default values, how the default values are going to be. And again, we have a default value of for only 5 different fields. So if we give 7 values, you're going to get the exception that you are supposed to have 5 value in here, not the 7. Okay, so why we have been doing this, these steps are nothing but use this in a pre-processing function. So what he's going to do in a pre-processing function is to take the line, this line, and set the default. If any of the value is missing, then he's going to set the default value for that. And if and then put them into a stack as in a TensorFlow, and just subtract the mean and divide it by standard deviation and return that value. So normalizing the values in here. So assumption here is X mean and X standard deviations are already created, which we saw above. I think he had here X mean and X standard deviation. And again, he used scale underscore. I'm not sure whether it's right or wrong, so I'll give it to him. Maybe it's right. That's what he's using, standard deviation down below. But I want to note down and do this research at scale underscore at a later stage. Okay, so going down below here. So that's the pre-processing. Now, one thing which he mentioned here is the decode CSV. So decode CSV is taking a line which we pass to this function, and the defaults, the record defaults are the defaults which we have in here. And the defaults he is giving whatever n inputs, we have 8 features. he multiply by 0, so we just passing 0 as a float, 0 float as a default values for first 8 features, and for the target, that's the default. It's a constant but no values, and it's a float value. That's what defined here. And then decode CSV is doing nothing but just set the defaults for them. I think that's all it does. Let me read here. Preprocessor function takes 2 arguments. First in the line to parse, and the second is the array containing the default value for each column of CSV. This array tells TensorFlow not only the default value for each column, but also the number of columns and their types. Okay, so basically decode CSV is sort of decoding the line which is coming in, defining them as a float values, what type is going to be of these fields finally, and what are the default which we specified in here. And then he says the decode CSV actually returns scalar. So he had to stack them into a tensor. Yeah, so this will stack these tensor. Okay, so the decode CSV function returns a list of scalar tensors, 1 per column, but we need to return 1D tensor arrays. And that's what he is doing. Again, anybody can shed some light between scalar tensors versus the 1D tensor arrays? Any idea? Anybody?
Scalar tensor is just one number, and 1D tensor is a vector.
So what would be the scalar tensors?
Single number. So it's just one float in this case for each column. And then we stack those individual single number tensors into a vector.
So that would be a 1D tensor array. So what the one which we are doing is when we are stacking these eight scalar tensors together, we are building a 1D tensor array. Is that correct?
Right.
So all in all is just creating an array of 8 numbers or 8 vectors.
I think X will definitely be a vector of 8 numbers, whereas like fields will be one number that you, yeah, so he's saying the decode CSV returns a list of scalar tensors. So each item in that list should just be one number. And then X should be, I guess, the 8 numbers as we stack.
Stack them together. So in a sense, in general, let's say if these are the 8 numbers, so once they are sitting in a continuous array, that's our 1D tensor.
Yeah.
Okay. So fields are like at the moment, for example, let's say the fields, this field is nothing but kind of this guy, which is like a normal scalar number, 8 scalar numbers just sitting beside each other. However, we need to put them into a 1D tensor array.
Yeah, you see the
I think if you
shape
look
is
at,
empty.
sorry, if you look at 137, I think the output of 137, because that's the output of a single line, isn't it? That's a TFIO decode CSV. So what that's giving you back is an array of tensors, each with a single value. So I think what he's sort of saying is he wants that to be one tensor with all of the values in it, rather than an array of tensors.
Okay, so decode CSV parsed field, and these are the parsed fields. So these are the five tensors, five, and then type we don't know. Data it says float, but okay. So we have a 5 tensors here. They need to be stacked together to become a 1D array.
Yeah, so if you look at, I think, what is it, output of 85, he's converted it into like a single tensor, hasn't it?
Okay. Yeah.
Which
yeah.
is which contains an array
Okay.
of all of those guys.
This is the tensor. Yeah. Okay. Yeah.
You can print it if it might be interesting actually just to print inside
So,
preprocessor print fields.
what do you want me to do? Just enter. If I enter it, this gives you returning values.
No, yeah, that's cool. Yeah, and I was just thinking, well, I'll take a look at it later and see what fields looks like. But yeah, I guess that makes sense.
Okay, so okay, that's that. And one last thing is, I always get confused. This -1, so I thought it's the last value he wants to take, but he says like he's taking last, all of the value but last in here.
In the first one, the
Yes.
is
So I guess with the colon, it's start and end, isn't it?
yeah.
So the start is not defined, so that's the beginning, and then the
Yeah.
end is -1, which is 1 from the end.
Yes, and -1 is the
So that's the start, which is 1 from the end,
yeah,
and the end is not defined, so it is the end.
it is the end. Yeah. Okay, we could have done maybe this -1 to -1. Would that be okay?
That wouldn't have got you anything,
No.
because that's an empty. Although I don't know, it depends on how they've defined it. That would be definitely be
-2
empty.
comes before -1, like that's.
Again?
-2 comes before -1. He does -1 to the end just to take the last element, but you see shape here is 1. It's not empty shape, but before it was an empty shape. And if you remove this semicolon, no, just this, yeah, it will return a scalar tensor again. Like
if I do this,
yeah, it will become a single number. But
okay.
when you have that, yeah, you see shape is empty of
Okay,
second tensor.
Yeah, yeah, okay. Yeah.
Yeah, but you need it to be like not a scalar tensor, but 1D tensor of shape 1.
Shape 1, yeah, that's your target. Okay, so that's that. So we take this one value and then we process it. That's what is coming, and this is putting everything together. So all he's doing is he's gonna take those file paths where we created a file, and again repeat how many times I think he's going to take. And again, always looking at them, I don't remember. Anybody remember? So correct me. Repeat is, I think, how many times he's going to dip into those files. And readers, number of files at a time. And read threads. And read threads is, I think this is something to do with the parallelism. At the moment, he's not doing any parallelism, but if he mentioned somewhere here, if you want to do the, I think somewhere here, prefetching, before prefetching, he mentioned somewhere that you can define how much parallelism you want in a program, or you can leave TensorFlow to determine based on the CPU cores you have in. And shuffle buffer size is like that's the buffer size. We discuss how much you're going to have the in the memory. That's the 10,000 bytes, I guess. And parse threads, I am not sure what's this. What's this? Oh, well, he may be using somewhere here, and batch size of 32. That's the processing. And anyway, this is what we did. We took the files, we repeated, and then got into a data set, and then interleave, we discuss again. We are reading 5 files that I think n readers. So 1 line from each file, and skip your header. And then afterwards, I think this is part of this function where it's defining like cycle length and numerical parallel calls. I think this is the internal to text line data set. It's passing in and establishing the parallelism. And the next stage is shuffle the data from the data set, storing in the same again. Apply the map process, which process we did here, which is normalization. We apply that, and then we did a batch. I'm assuming we're creating a batch of a size 32 here. And this function prefetch, which you mentioned, we're going to see here. Let's have a look in here. So prefetch. Okay, so this figure explains prefetch quite nicely. So prefetch is if you use a prefetch, and if you don't do a prefetch, your CPU is preparing a data for you, all these steps you're doing, and then you're passing over to GPU. And then once it's finished, your CPU start working again, and then pass on the data to a GPU. If you use the prefetch, so you prepare the data, pass on the GPU, but at the same time, while GPU is processing the data, you are fetching and preparing for the next batch, and so on and so forth. So here you are, with the prefetching, you are establishing parallelism. So that's what the prefetching means. Again, if you have multi-threaded, multi-core CPU, which latest laptops are, you can have prefetching added with the multi-threaded loading, which will, your multi-core will be helping to build data quickly for you and pass it on to a GPU. And obviously the GPU would be like 10 to 15 times faster than the CPUs for you. So you will establish huge amount of the parallelism in your process with the prefetching. And that's what the prefetching is in here. Okay, so that's that. And going back in here, we start again. We have training files with the base size of 3, and then we just gonna print them. Let's print them. So just applying this function in here on a training set, we got the base size of a 3. So that's the 1 set, that's the 2nd set, that's the 3rd set. So base size of a 3s are coming, and we just took the two sets as such. So this is 1 set and 2 set. And basically all he's trying to establish here is, rather than we go in a loop, in a sequence, this is how you can establish parallel processing and passing on to GPU, sorry. And again, what we have demonstrated here is going to do the same here with the training, with the validation and a test. Let's do that. And he developed the, now here we have a model with the 2 layers. First layer, 30 neurons, second is just flatten out, rally the function, and then actually where we haven't passed the data yet. So that's your model, and MSE is the loss function, optimizer is SGD, learning rate is LE -3, and we have a batch size of 32, and in here we send the training set, and training set is nothing but what we created through a CSV reader side, and reader side is nothing but creating the data set for you. So we take the data set, pass into a fit, and then it will process your data. Instead of we passing the whole training set, now we are passing the set of rows through the data set whatsoever. Make sense? Here, similarly, as we have been using xtrain, xtext, or xvalidation, you can use, instead of the set, the xtrain, you can use the xtest, you can use this test set which you created above, and that will give you the prediction in here. Okay, and we could just pass test as Kira would ignore the label. So if you have the labels already, it's gonna ignore the labels. That's what he's demonstrating here. And in the next three sets, 1, 2, and 3, all he has done is nothing but just training and displayed the method. So I'm gonna go to the last one, which is going to show method is same. What we have demonstrated above, he has done again, but it's more clean fashion. So I'm just gonna run this guy in here to see. Yeah. So we have total of around 1800 of number of steps we have in here, and steps are actually defined here. So steps are nothing but is the steps per epoch, which is the length of your training data divided by batch size. So that's your total steps, and then he's printing the progression after every 100 in here. That's pretty much it. Yeah, and in here he is just showing you all the method available with the data set, which we saw initially. So these are the methods which can use the filter, element spec, cache, blah, blah, blah. These are the methods available for us to utilize it. In here, I think, yeah, so there are other methods he mentioned: concatenate, zip, windows, view, shard, flat map. These are the methods which you can use with the data set itself. I think he has, oh yeah, here the only difference between the above and below is in here he's using a zip. I think above he wasn't using the zip. I know he's using a zip. Yeah, he's using a zip. So I think there was slight difference between this method and this method. There is not much. It's just expanding in here. Okay, and I think that's pretty much it. This is all. Yeah, this is all he's doing in here. Yeah, I think that's pretty much it. Yeah. All right, that's pretty much it from me.
Thanks, Tash.
Okay, anything we want to discuss, or we close off then?
Yeah, it's
Okay.
not an yeah, okay. It's not an easy one to discuss. I think it's just something you have to play with to get around.
Yeah, I think I gone through this once. It made more sense when you start playing here on the left. It would be nicer if I can type, but it takes me ages. Like I need a couple of days to do it. But it still makes sense if you read here and then come back and then do it. So yeah, definitely recommend it to do it.
Okay.
I just wanted to ask if anybody has experience with Hugging Face data sets, you know,
Oh no.
What do you mean when you say data set?
Hugging Face data sets, that's a library or
Oh, the library, right? Okay. No, Musgrave, I've only used a couple of their pre-trained BERT models.
So I was working with this data sets, and I have like a big drop in performance when I use a larger data set. So I have like model trains much faster with a small sample, but much slower with full data set. So I think it's like something similar to what we was looking here. So I need to figure out how to prefetch effectively the data.
Yeah, I mean, do you have a GPU, or are you doing it on a CPU?
Yeah, I was running on Colab, and I was using GPU.
Right. Because usually all this prefetching and stuff like that is unfortunately only a very small. I don't know, can you do profiling in Colab? Because yeah, unfortunately all of this Python related stuff that Dinesh is mentioning, normally in terms of training and evaluation, this will be probably less than 10%. So, yeah. I mean, if you want to improve the performance, you might have to have a look at the batch size you're using to see if you can push that up a little bit. So there's fewer iterations. You can push more to the graphics card in one go. Things like that.
Yeah. So, but I was using a reformer model. So it's like designed to use a really long sequence length, and it's like already using a lot of GPU even with a small batch size. So
right. I guess even if you could increase it by well, yeah, a couple. I don't know, what batch size are you using?
So I'm using a batch size of 2 with a sequence length of 16,000 tokens.
Okay. Yeah, I mean, if you could, even if you could increase that to 4, that would still halve the amount of GPU going back and forth.
Yeah, I'm gonna try it and see if I can fix some.
But in terms of your rate, you were saying you got worst error rate with the bigger data, but that makes sense because the smaller data would probably have been overfitting. With the bigger data, there was less of that, so you'll get a more kind of better model, but the error rate is going to go up. That would be my hypothesis.
Yeah, but I didn't meant error rate when I said performance. I meant like time per iteration. So
yeah, 16,000 is a very long token length, I have to say.
yeah, but that's that was what was I'm curious about this reformer model. It like allows. It's designed to they in paper they used like 64,000 lengths.
Oh, okay. The other one is Big Bird, which is supposed to be quite good with longer sequence lengths because they don't use the full attention mechanism. They do a kind of a sparse mechanism.
Oh.
But I don't know if that would cope with 16,000 because that's actually really big.
In this reformer model, they too changed attention mechanism. They used this hashing, local hashing.
Oh, okay.
Locality sensitive hashing is called. So just different approaches to attention.
Yeah, I've been meaning to read that paper, but as with anything, there's just so much to do, so little time.
Yeah.
But yeah, have to see if you can up it even to 3 for the batch size because that would still improve it. Yeah.
Okay, I'm gonna try it. Thanks.
How's the paper group going? Is it still going, the NLP paper group?
Yeah, we're meeting reasonably regularly, so long as I'm not too lazy on that day. We're actually looking at one of the state-of-the-art models at the moment called text-to-text. It's a variation of the transformers model for it's the state of the art on the superglue benchmark at the moment for most of the tasks. Yeah, really interesting work. So yeah.
That's moving too fast for me.
Yeah, if you're not into NLP, unfortunately, things are like just so. There's so much to learn now.
Yeah, yeah.
Are you going to try and specialize in reinforcement once you finish, or have you had enough?
No, I think it's a really interesting area, but you know, basically I'll have to see what happens next. So I'm not going to restrict myself. Yeah.
Yeah, cool.
Well, guys, I gotta go now. Thanks very much.
Yeah, thanks a lot, Dinesh. Really appreciate it, and yeah, really good session. Thanks.
Thank you.
Thank
Yes.
you.
Right, bye.